Okay, today I just wanted to quickly talk about a few things. First off, there's it's widely known in the emulator community that the 2600 is actually not that easy to emulate, and that even with modern fast computers, getting the timing right for the system is a challenge. So that's kind of given people the misconception that you have to have a high-end computer, or at least one of these newer, faster ARM chip tablets, something. You need something with a little more kick to be able to emulate Atari games properly. And I mean emulate them, without too many problems. But you don't actually need Stella or one of these newer ones that you set up yourself. Like maybe some that were based on the MAME or MESS emulators that started with arcade emulation and later evolved into emulating everything. So today I'm showing how you can program on a Pentium II. Okay, this is a Pentium II I have that's a laptop that the screen broke, the battery died, the 3.5-inch floppy drive broke, the CD-ROM broke. Eventually, the only thing that was left was the keyboard part of the laptop, the body of the laptop. I took the screen off. Fortunately, the USB port still works, the PCMCIA slot still works, and it has TV and monitor out. It's a Compaq laptop. You can see here that it's a genuine Intel Pentium II, 64 megs RAM, Microsoft Windows 98 2nd edition. Okay, it says I'm configured for optimal performance, and I have 84% system resources free. When do you have that free on a modern system? And this is a zippy little system. I have a KVM switch and several different computers hooked up. The KVM switch lets you hook up multiple systems to one monitor and multiple USB devices to the monitor. So this system's set up to do all kinds of stuff, but it can actually be used to program and test your pre-console test through emulation, Sega games and Atari games. Also, probably 7800 games would work fine on it too. So you're not using visual batariBASIC because that requires a little more than what's in 98. You'll use normal batariBASIC that goes through command. Now command opens a DOS window, but this isn't DOS, this is within Windows. So you have the longer names. If you're going to use it in DOS, you have to set it up for shorter names, and there's instructions on that in batariBASIC. So I'm going to talk about a few things today. First off, so you're going to be programming in a text window. You could use Editor, Notepad until it gets too big, and then WordPad. So I've got my file here. The Star Trek game, I'm calling it tentatively Space Navy, is a WordPad file. I went ahead and put my source and includes from batariBASIC in the folder with it, and I'm in MS-DOS prompt. I've already tested this. This is actually command though. This isn't DOS because, like I said, DOS isn't going to recognize the longer string names. I'm in my folder here. And so you're either going to set up AutoExecBat to give the directories for batariBASIC to work, or you're going to run a program within batariBASIC that installs it into Windows outside of using visual graphic user interfaces. There are other graphical user interfaces other than just visual batariBASIC. I just use visual batariBASIC because it's the first one I used and it's fun, but it is, just like Stella, it's kind of deceptively resource intensive. You really need a good system with everything running well, lots of room and lots of speed to get everything to run right. For instance, I have a relatively good laptop, but you have to fish around to find the right version of Stella to really match up with it, because the newer Stella doesn't match the refresh rates. The older Stella won't run fast enough. So somewhere in the middle there is one that will run fast enough. It takes a few seconds to load a full like 32K bank switching program once all the banks are all starting to get filled in. It's a slower running process, even though it's a relatively good laptop. I have a gaming rig that's got, you know, a really good gaming graphics card and good processor, lots of RAM. It's faster, and it runs everything great, of course, but it's a, you know, more expensive gaming computer. I have an upgraded system that I use commonly for programming, and it's fast enough and everything's fine. But this is if you just have some old junky PS or a Pentium II, the old PS2 style hookups, or fresh USB 1.0, the beginning of USB 2.0 generation systems, you can still program. So I've got my thing in here, my it's, you name it, a base file, BAS. And you see I have, here it is, my 2600, the basic variables are in here. I've also got space n, that's my file, as a BAS file. So if I type 2600 BAS, and then I'm going to type space n BAS, this will try to compile it. Let's see. Of course, it gave me the first fail here. Maybe I have to all caps it. Let me see. Nope. Okay, so when this happens, I'll go ahead and switch to smaller window. I'll go ahead and open it, and then just save. Let's see here. I'll save it again. I don't need those. Okay. Yeah. And it's filling. I just had it successfully compile. See here, we're 2600 base, and here we go. It ran through. All I had to do was save it in a different format so that it would correct itself. And I saved it in a MS-DOS format. It went through and found all the different banks, and here's your end report. Just like what you'd get in Visual batariBASIC, of how much is left in each bank. Of course, if you're using just one or two banks, this is only going to be 2 lines. 4 banks is only going to be 5 lines, and so on. I'm using a 8 bank, 32K bank switching, and so it's showing each of them. And this is a brand new game, but because of this, I can go into a editor. Let's see, I'm going to start, there we go. And here's where I'd be doing my editing. So this, just like with Visual batariBASIC, you're going to be in a window typing stuff out. You don't have the color coding, so it might be harder to detect problems before you go into compile. Now I've made the file. Here it is as a bin, and it creates the assembly for it, the includes files for batariBASIC, because it's going to be attaching the kernel options based on what you're setting the game up for. And in my emulator folder here, I've got my Atari emulator Z2600 version 2, and I'm going to move my my game bin file over here, my binary file. Bin is binary. And I'm ready to go. Now I've got it in here with a couple of other games, just a few so it doesn't get too cluttered. Now we're going to check this out. Now this is Z2600. It's not Stella, and it's not a modern one. I don't know if anyone uses this still, but I found out something about this that I actually am very much interested in. Okay, now it's it's kind of hard to read what's up here, that's fine. But if you look through the options here within this game, this explains everything almost like it's a quick reference help file. And as I'm going through this, you have your different graphics modes that you can switch through. Okay? But if you check out down here, within these graphics modes, you have E here. This is a 32-bit Mode X 160 pixel linear video mode that enables flicker and interlaced games. Now, interlacing. Okay, now to interlace your screen is going to eliminate any kind of flicker or anything bad, the things that you might not like on something that's emulating the system, I guess more accurately, but it makes me wish that I had a way to make the game look like this on a real system somehow, because it looks so good, and I wanted to show that. You also have half-size alternate scanline display. They're just for the first 4 video modes. Okay. And then you have this one. Now this one here I used. It says, and these are command line switches, and the way it does command lines is in your shortcut, or however you're going to open Z26. You add the command lines, then you open the game, then it adds them to a configuration file. I think it's a CLI file, something, a client file. Then you delete the lines from within the shortcut, and then run it again, and those settings will be in it. You can still, of course, you can change all the settings while it's running. But this last one says simulate interlace in video mode 6. This makes an extremely good looking picture, and I'm going to go ahead and show that now in that game. This is the Space Navy game that I've been making, the Star Trek game. Okay, now you can see how this screen is looking. Okay, got some lines running through it. Now I've set it up to, you can move of course, but I've set this up to change. There's the ship again. There, and I can change through the ships, and I can also do a zoom mode here to show the largest zooming mode of the game. So I'll go ahead and do the middle point zooming, and then I can switch through, and I've added some ships, like your Romulan Warbird, Ferengi ship. Okay. There's your star base. There's, my son said I needed to put the nacelles higher on this, like a kind of a friendly ship. Now, of course, you know, the sync line isn't in it. And you can see it's kind of a scan line mode, but everything is really solid and perfect. And it meshes the screens that I'm using perfectly. It just looks really, really great. I'm really happy with it. The Ghost or Bust game is equally good. So this is Z26 a 2600 emulator that is not Stella, and let's see, this kind of, my camera scooted on me. But yeah, it's not Stella, and it's not running on a newer system. This is on a Pentium II, what's it, 233, relatively fast Pentium II. Here's the fighting game I've been working on. You can see the reflection from my other television going on here. But, we're going to go two-player mode here. See if I can't move this. The point here, though, isn't to preview, you know, or to show off progress of the game, although more progress has been made. The game's almost finished, of course. I've done the one-player and two-player story modes now, so that the characters progress as they change and everything as you're running through the game. Got some more moves in it. Can't play two-player here. I'll try to. So you can see the screen looks pretty good. I wish the lines weren't running through. This would be so good if you could see how well it synchronizes. There we go. Okay, got some more special moves going on. Anyway. So that's Z26, the Atari emulator, and even though out the gate it looks a little flitty, a little jittery and a little skippy and everything, a little flickery, once you set it up the way you want it, then it looks really, really great. The emulation is great. So another special surprise I found, because as I was running through all the different steps of creating, I used the imgtoCode graphics converter that's in Visual batariBASIC, and I was pleasantly surprised to find that it works fine on Windows 98 2nd Edition on my Pentium II. It's going to take a second to load. This is just a 64 megs of RAM, 233 megahertz Pentium II. I think it might be 233. Hopefully it's not 266. Either way, it's Pentium II. But once it loads it up, here we go. So this works. And so if you're going to draw your graphics using a paint program, like I like to do, then you can use this imgtoCode converter to turn your drawings into Atari graphics, and then you can copy and paste them into your whatever text editor you're using to make your game. Now I also found out that the BasiEgaXorz, which is what I use to program Sega games, it's really, really fast, very low, as low level as BASIC can get. I mean, it's all static, as it says in the instructions. It's made for speed, and it is extremely fast. You can make great games using it. Now, it uses ASMX for the newer versions, and those won't work. But the older version of the programming environment actually does work on Windows 98 Second Edition. So I've got BasiEgaXorz here, and if you haven't seen that yet, here it is. It's, just your standard BASIC, but it comes with a couple examples, and programming on the Sega Genesis is really, really fun. And of course, the older emulators like WGen, that's what this is, work fine on a Pentium II. This works full speed. It works great. There's nothing wrong. Maybe this will work. Let's see. There we go. This was a demo that I did. I'm going to go ahead and use my joystick to play it. A demo that I did a while ago of Nadia walking on a beach. Oh boy, the lines. It looks terrible on that camera. Sorry about that. But yeah, there's pretty much nothing I can do. Let's see if I can zoom in. There we go. That helped a little bit. Just to kind of give an idea, it's the same as any other, Sega Genesis type of programming. Today, of course, there's the Sega Dev Kit, which lets you just draw sprites and drop them in. This is a little harder than that, as you have to space everything out just right. And well, it doesn't do everything for you. I mean, it's newer and a little more integrated. But this is what I learned on, and so this is what I use, and I really enjoy it. Now this is very simple. It's a single color background with a large animated wave sprite, and then several different animations. I think it's maybe 2 or 3 sprite blocks for every facet of the girl walking. And I've just got her walking on the beach. Now since then I've done a lot more stuff with BasiEgaXorz. I've done backgrounds, fine scrolling backgrounds, and lots of sprites and slideshows and things like that, just to learn the ins and outs of it. And I've learned that you can actually make 32X and Sega CD games with BasiEgaXorz, and I made a Sega CD of this, only with background music and different songs I wrote, playing through the whole thing. So suppose you don't want to program the background music, you just want to make music to put into your game. Well, you can use a Sega CD, and of course, because everyone can emulate very easily Sega CD, you can just have an image file that's comparatively small, but it gives you upwards of hundreds of megabytes of space to program your game. So I guess you can be as wasteful and sloppy as you want, and as long as you can keep things running fast enough, you could have a good game for Sega Genesis. Now this is pretty fine. It's only like, I don't know, 58K or something when it's all said and done. But this was one of the first things I did on BasiEgaXorz. Now she's not mirrored. If you notice, her right side of her head doesn't have a flower in her hair, and her left side of her head does have the flower in her hair. So she's 4 different facets, left, right, up, and down, are all different. Lots of graphics, deceptively more graphics than what appears. Okay, so this is my Pentium II, and you can program using batariBASIC. You can compile it using the 2600 base compiler. You can make images using the same program that was in Visual, batariBASIC. You can use MT-Paint, which is what I use to draw. You can use imgtoCode here to convert your graphics to Sega Genesis data and palettes. You can emulate Genesis, you can emulate Atari, program Genesis. This is all, and it all runs great. This runs my Sega Genesis games full speed, no problems. It runs my Atari games very well. Of course, you're going to want to program this stuff and test it on real hardware. But You don't need high-end or higher-end or newer stuff. You can find some old junk Pentium II and still do all of this stuff.